This week we learned about branching and jumping instructions, which we used to emulate if statements. Today we're going to have a look at how we can use these to create loops. So just a bit of revision. Remember that a jumping instruction just allows us to update the program counter to where we want it to go in memory. We use this as a label. We put a label at a certain point in memory or in our program, and we tell the jump instruction which label to go to next. And this allows us to move about our code to do stuff, more stuff, and even more stuff as we see fit. Now on the other hand, we have branching instructions, and remember that branches allow us to jump if a condition holds. If a condition does not hold, we just keep going through the code as we usually would, incrementing the program counter at every step. So these two tools are what are going to allow us to make loops. So let's take a look at an example. Here we have the sum of squares. Now it's a fairly simple loop. We just loop from 1 up to n, adding the sum of the squares as we go, where the sum of the squares are, for example, if n was 5, we would do 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, and that would be the sum of those squares. So let's have a look at this MIPS code and see how we do that. Well, first of all, we load our immediate values into the registers V0 and T0. V0 is going to hold our total overall, and T0 is going to hold our index. So we test to see whether or not T0 is greater than n, which would be stored in A0. And then we jump, if that is true, we jump to the end loop. But you'll notice here that we're saying that branch greater than, so we're not testing to see directly that I is less than or equal to n, we're testing the opposite. So we're saying if it's greater than, we want to jump out because we've failed our condition. So that allows us to jump out of the loop by breaking the condition at the start, or meeting the opposite condition in this case. So then we would do the multiply. We would do T0, storing in T1, T0 times T0, and that would give us our I squared. And then we add that value into the value in V0. So we're using T1 as a temporary register to store the intermediate value, and then summing V0 as our running total. Then we add immediate value of 1 to T0. That's incrementing our index I. So that's the I++ at the top there. And then we jump to the top of the loop. So you'll notice that we have the condition at the top, and we check that to see if we should be breaking out of our loop. And when we get to the bottom, we jump back up to test that condition again. So this is a relatively straightforward loop, but let's have a look at another example of a different type of loop. So here we have a while, and in this case we're trying to count up the number of bits that are set in a given word. So we're saying the 1 bits are equal to 0, and while the number itself is not equal to 0, because if the number is 0, there are no bits that are set to 1 to count. And what we do is, we do 1 bits equals 1 bits plus, and the way we find out if a bit is set is we AND the value with the value 1, which will tell us if the rightmost bit is set, and then we shift to the right. So we're going to shift our bits down, and they'll all eventually go through the first position, and if we AND it with the value 1, we'll get a 1 to add on to the number of 1 bits if it's successful. So let's have a look at how we do this in the MIPS. Well, again, we're using V0 as our counting register, so we'll be summing into there. And so we branch to see if equal to 0, and if it is equal to 0, we jump out of the end of the loop. So that's directly reflecting the condition of, well, it's not 0. So in some cases we can use branching instructions to directly reflect the condition. Then we use our AND I, and this is exactly the same as the condition above, where we just AND the value with the value of 1. And then we add our total, and we shift right using the logical shift right instruction, and jump again. So this is it's quite similar to the previous version, but instead of using a for loop, we're using a while loop. And you'll notice here we don't have any index to increment, because we're using a while loop, not a for loop. So we don't need to check that we're less than n, we just need to check that a given logical condition holds. So let's have a look at one more example. Let's have a do while loop. And this is a factorial. So while n is greater than 0, we want to calculate the factorial value. And the factorial is, of course, a number times by all the numbers before it. So a factorial of 5 would be 1 times 2 times 3 times 4 times 5. So we times it all back down, and that's it. So here we have factorial equals factorial times n, where n is the value that we're trying to find the factorial of, and then we decrement by 1. So every time we take 1 off, so if it was 5 the first time, it would be 5 times 1, and then we would do n equals n minus 1, and then it'd be 5 times 4, and then we do n equals n minus 1, and it'd be 5 times 4 times 3, and so on, until we get to n is not greater than or equal to, or not greater than 0. So here we load an immediate value of v0, 1 into v0, sorry, and then we enter the do loop. And what we do in here is we do the multiply value, assuming that a0 is storing n. So we multiply the value that's in v0, which will be 1 in the first case, but will be a running total as we get going, with the factorial value of n. And n then gets decremented by adding immediately the value of minus 1 onto it. And then we check the condition and jump back up to the start while it's true. So you'll notice the difference with this loop is that we put the branching condition at the bottom of the do loop. We don't check it as the first matter of course at the top as we did previously. So this is just another example of a loop you could build using MIPS. But that's everything I wanted to cover today. I'll be uploading some more examples so that we can see how we build, for example, printing loops in MIPS. I hope you found this video helpful. If you have any questions about it, please do let me know. Thanks.